A block of mass m is attached to two unstressed springs of spring constant K1 and K2 as shown in figure. The block is displaced towards right through a distance x. The block is displaced towards right through a distance x and released. Find the speed of the block as it passes through the mean position. Okay. So here also, if it is displaced initially, it will store some potential energy in both the springs. Okay. And then if it is relaxed, after reaching to the original position, it will lose that potential energy stored, and those energy will appear as kinetic energy of the block. Okay. So while relaxing the spring, while relaxing of a spring, the work done by external force, if you see, what are the different forces? One is normal, then there is gravity, and there are spring forces. So gravity and spring forces are always part of conservative force. Normal force will not be able to do any work, okay, because it is perpendicular to displacement. So we can write delta K plus delta U equal to 0. Okay, so delta U spring we have to write because gravity is not doing any work because the object is moving along horizontal. So change of kinetic energy. So the object was what? Moved and then released. So when it was released, the initial velocity will be 0. And finally, suppose V. Okay. So we are writing this thing, the expression between which point? Between the stressed condition or the displaced from mean position to the relaxed position. Between stretched and relaxed position. Okay, so when it was stretched, the kinetic energy was 0. Okay, and when it is relaxed, the kinetic energy is half mv square. This is velocity at mean position. Velocity at relaxed position. Okay, relaxed position, and this is velocity at extreme position or stressed position. Velocity at stressed position. Okay. Plus, what is change of potential energy? So final potential energy will be 0. Initially it was stretched, so half K1 x square. One spring was stretched, and the K2 was compressed. Half K2 x square. Both will have the stored energy. So we can write like this. So final energy is 0 because both are relaxed, and initial energy will be half K1 x square and half K2 x square. This will be equal to 0. So if we solve it further, we are going to get V square equal to x square K1 plus K2 divided by M. So V is equal to x under root K1 plus K2 by M. Okay. So this will be the velocity of object when it reaches to the relaxed position.